Okay, we're going to talk a little bit about the zero product property and what the zero product property is telling you. So it's saying basically if you multiply two numbers together and the answer is 0, then either one of the numbers or both of the numbers have to be 0. So we use that when we're solving quadratic equations by factoring. So let's take an example here. Let's do x squared plus x equals 42. So if I were going to solve this one by factoring and using the zero product property, first step is I have to make the quadratic equal 0. And I do want to put it in order of the quadratic term, the linear term, and the constant term. So keep in mind, to move the 42 to the other side, you do need to do the inverse operation. So we're going to have to subtract that 42 over. And then we're going to draw our parentheses. And again, like we've done in the past, what makes x squared? That's going to have to be x and x. Then you got to think about 42. You know, you got 1 and 42, you got 2 and 21. I don't know, we got 6 and 7. You got lots of options there. I'm noticing that 6 and 7, though, that would give me a 1 in the middle. So if I did positive 7 and negative 6, that would work. Now I'm saying that this thing times this factor is giving me 0. So that means that one of those two parentheses must equal 0, or even both of them. So we bring them down and we set each one equal to 0, and we solve from there. So this one would be negative 7, and this one would be 6. So those would be our solutions. Remember, solutions, zeros, x-intercepts, those are all kind of referring to the same thing. And remember, I've talked about this earlier, the relationship there. You've got a x plus 7 is the factor, but notice x minus 7, or x equals negative 7 is the actual solution. Okay, so let's try another one that has a coefficient. So this one, 2x squared equals 9x plus 5. So step 1, make it all equal 0. So do your inverse operations, subtract your 9, subtract your 5. Now there's a couple ways to do this one. One of the ways you probably learned in the past was by grouping, or some people called it the trident method. Lots of different methods there, but you kind of multiply these two out here together. So if I multiply 2 times 5, that negative 5, I'm going to get negative 10, and I need to think of two numbers that multiply to be negative 10 but would add to be negative 9. So in this case, I would do negative 10 and positive 1. Okay, so I'm going to do 2x squared, and instead of 9x, I'm going to break that up into what can also be 9x. So if I did negative 10x and positive 1x, see how that would make negative 9, and then minus 5. So I'm just rewriting it a different way. I haven't really changed the value. Now when we do grouping, you group the first two and the last two together. So the first two, what they both have in common is a 2. They can both be divided by 2, and they both have an x. So we pull out that GCF of 2x. To get what's left over, it's a couple ways to do it, but I always think 2 divided by 2 is 1, x squared divided by x is x. So I'd left with an x. If I do the next one, negative 10 divided by 2 is negative 5. X divided by x becomes 1, so I don't have to worry about it. On the second one, not a whole lot in common, really. The only thing you could divide both of those by is 1. So I'm going to pull that 1 out. So 1x divided by 1, I'd still have x. Negative 5 divided by 1, I'd have negative 5. Now when you do grouping, these two should match. That's how you can tell you're doing it right. Those two have to be the same. And really, they have become a common factor to the whole problem. So I'm going to pull out that x minus 5. So think about it. If I pulled out this x minus 5, you'd have a 2x left here. If I pulled out the x minus 5 there, you would have the 1 left. Okay? So grouping, kind of a nice simple way to do these without a whole lot of guessing. Now that we're back to our factors, we can set each factor equal to 0 because we're saying, hey, we're going to multiply these two things and they're going to be 0. So I say x minus 5 equals 0 and 2x plus 1 equals 0. So I get 5 there. This one I got a little more work. I got to move over the 1 by subtracting, and then that 2x, opposite of that, would be to divide. So I can see there's my two solutions by doing factoring. Okay. You can always, if you're doing this by yourself and you're not sure if you're right, you can go to Desmos and type this equation in, and you can see if you get these two answers as your x-intercepts. That would be a good way to know if you've done them correctly or not. Okay, so I'm going to have you pause and you try these two in your notebooks. Okay, so hopefully you hit the pause button, and let's see how you did. So we subtract our 20 over, and then we need to think of some factors here for 20. So 10 times 2 is 20, and I know plus 10 minus 2 would make the 8. And then I said each one equal to 0. So I can see x is negative 10, and over here x is 2. So again, that means that's crossing, the parabola is going to cross at those two spots on the graph. The second problem that you guys tried, I always like to keep the x squared positive, so I'm more inclined to move the 3x plus 2 to the other side. So don't forget to do your inverse operations. And we are going to do the grouping method. So 2 times negative 2 is a 4. So how could we break 4 up to be negative 3? Well, we could do negative 4x and positive 1x. So I'm going to rewrite that as negative 4x plus 1x minus 2 to do my grouping. The first two and the last two. So the first two have a 2x in common. Again, you're dividing. 2x squared divided by 2x is 1x. 4x divided by 2x would just be negative 2. This one over here, the only thing I can take out of those two, or factor out, would be a 1. So if I divide those by 1, I would still get x minus 2. And remember, we're looking for those two to be the same. That's one of your factors. The other things, or the other factor, are the things out front. So basically, we're doing a GCF and a GCF. Kind of crazy. Okay? And then we can set each one equal to 0. And solve. So we get 2. Oops. Subtract that one over to the other side. And divide. So again, if you're having trouble, make sure you're using Desmos to check your answers if you're not quite sure. You can also look at the worked out solutions here.